question mark. Okay, so it's kind of interesting actually.
Yeah, because it's not a normal function equation.
It's actually it's easier than a normal one, surprisingly. Okay, you have a set of primes, yeah,
It's oddly specific. Yeah.
and to the set of primes, yeah, the set of all prime numbers, yeah,
Oddly specific.
and I guess they're positive, so whatever. Yeah, so
Wait. Oh, again now, because like it has something to do with
Primes have
parity.
to be positive, yeah.
It's something to do with parity, because like odd and even. That's why it's like
yeah, we finally
two
did it.
I'm so dumb. I'm so dumb.
Don't worry, no one else saw it either.
What? Oh, parity. Okay, because like Pete, an odd number to whatever power is also always odd.
But like, that's not the case, because if you sub in 2 and 3, you get something weird. That's the thing. I'm so dumb. How did I not figure this out?
Yeah, so basically you sub in 2 and any other prime, yeah?
Yeah. Okay,
Obviously, if you sub in the same, can you see if you sub in the same thing, nothing happens, right?
Yeah.
Yeah,
Because you get equals to equals. It just cancel everything, right?
Let's try 2 and 3.
So sub in, say like P equals 2 and Q equals 3, right?
Yeah.
Then you get f of 2, f of 3
Plus 9.
plus 9 equals f of 3,
F of 2.
f of 2
Plus 8.
plus 8, right?
Cancel 8 from both sides.
So f of 2, f of 3
Plus
equals
minus f of 3, f of 2 equals 1, right? So they have to both have opposite parities, right?
Which means that either f of 3 is equal to 2 or f of 2 is equal to 2.
Yeah, so either f of 3 equals 2 or f of 2 equals 2, right?
Oh,
It's just
odd
not
and
even.
even because
So
like
this is odd,
an odd
this
number
is even.
to whatever number.
This is odd, right? One of them has to be odd, one of them has to be even.
Yeah, that's right. So then maybe we could try f of 3 is equal to 2, but and you can prove it.
And an odd number to whatever power is always. Integer power is
You
always.
just have to get different cases.
Yeah.
Just try
So like.
But it's crazy because look at it, like if f of 3 equals to 2, right? If an odd one equals to 2,
Yeah.
you have two odd numbers, right?
Yeah.
You'll be even, right?
Yeah.
That'll be even, yeah?
Yeah.
So the other one has to be even too, yeah?
Yeah.
Yeah.
So basically, if f of 3 equals 2, then everything has to go to 2, right?
Wait, if f of 3 is equal to 2, then f of 2 is odd.
But that doesn't make sense. If
No,
everything.
no. If f of 3 goes to 2, I think f of 2 would... Okay, no, f of 2 is different because 2 will give you an odd number here. That's the only thing gives you an odd number, right?
Yeah.
Everything else gives you an even number here, right? So, if f of 3 equals 2, then f of all the odd primes is equal to 2.
F of 3 equals 2, then f of. Why? Except for 2.
So put your phone away or I'm never going to answer your questions, you understand? Because you just don't listen to the answer and then you ask it. It's really fucking annoying, okay?
Always sense yourself. Just say it. Just say it's really fucking annoying. Shut up.
Really annoying. Yeah.
Okay.
Sit down.
Well, I just realized if everyone was equal to 2. Wait a second. Well, that's not good.
Yeah, right? So if this happens, right, then f of everything is equal to 2.
Because why?
But for the same reason, because see the only reason you got 1 here, right?
Yeah.
Is you put an odd and an even, yeah.
Yeah.
But if you put odd only, right, you get even here.
Yeah.
Right.
Oh yeah. Okay, I get it.
And if that's even too, then the other one has to be even, whatever you put, yeah.
Yeah.
So the only even prime is 2, yes.
Yeah. So
Yeah.
like for everything that's not 2, you have to be FP equals
Yeah, and then f of
2.
2 equals something odd, yeah.
Which
But-
means that's actually one of the solutions. F of 3 is equal to 2. Is that one solution?
Well, you can just check, right? So you can check that it doesn't work, yeah.
Well, it's
So like, if everything's equal to 2, right, then this cancels, yeah?
Yeah.
But then this doesn't, yeah? Because the original primes can be very different,
Oh
right?
yeah, true. Never mind. It can't be 2, so that's out of the way. We can. So it has to be f of 2 is equal to
F
2.
of 2 equals 2. And can you see that also proves only 2 goes to 2, right?
Yeah.
Yeah? Because
Because
if
you have
anything else
anything
goes to
up
2,
then you
that's
just sub
the
P
same-
for the other number and it doesn't work.
it's the same principle,
Yeah.
yeah?
Big brain.
Okay. So that basically solves the problem, okay? So actually there's an interesting comment I want to make in this situation. So you have the basically this situation is an equation x to the power of y minus
Y to x. Alright.
that's y to the x equals 1, yeah?
Wait, there's only one solution. That's clearly 2 and 3, right?
Oh, this is like the Catalan conjecture or whatever. So that's why I think the fact that they use primes makes it easier because you don't have to use like a crazy theorem like that, right?
theorem? Like, I'm confused. What
Oh wait,
this?
is it? Hold on, what was
It's
it?
a theorem of conjecture. What the hell
Is
was
it x to the a and y to the b? Anyway, but the thing is, if this was for all integers, you might have to come up with something different.
Well, this ain't good.
At least you would only know, like, the parity wouldn't be enough to conclude it's 2 if it wasn't prime, right?
Actually, x is equal to 1, y is equal to
Yeah,
2
'cause
also works.
Because there's like,
Yeah.
you have to get that out of the way as well.
And also, so there's a x is equal to 1 and y is equal to 2. That also works.
Yeah.
So what's Hybein talking about like a double induction for this or something?
Double induction. Oh, hell no.
Double
Oh, I don't know. Look at this. Just
Yeah,
watch
that's
this,
that.
okay? Like,
The fuck is double induction?
you guys get scared by the stupidest things, okay?
Yeah,
It's hard to respect this,
We kind of do.
but it's
Double-
alright.
Imagine doing double induction.
What's double
But look, okay, so we got f of 2 equals 2, yeah?
Yeah.
By the way, can you see, so in the equation, can you see that identity works? Because of the way this equation is set up. Identity is the solution, yes? So f equals identity is the solution, yeah?
Identity.
Which
was an
identity is f of x equals x.
Okay, that's the identity function. Yeah.
Yeah.
Doesn't change anything.
And it works, right?
Yep.
So the thing is, you can put 2 in there, right? What do you get when you put 2 in there?
Well, you get f of 2 is equal
So you get 2 to the f of q, right?
to plus q squared
Plus q squared
is equal
equals,
to f of q to the power of 2
yep, f of q squared, and then 2 to the power of q, right?
plus
Plus f of q, yeah?
squared.
Yeah?
Difference of
So
squares.
one thing you could do, look at this function. So you rearrange this 2 to the f of q, right? Minus f of q squared, yeah? Equals 2 to the q minus q squared, right? So I'm basically copying Hybein's solution now, okay? Can you see that basically this is like a function, right? Like if you think of it as an integer function, you have like 2 to the n. Like if you have like g of n equals 2 to the n minus n squared, right?
Yeah.
Oh,
Yeah.
Yeah.
Can you see the point of this function is increasing function?
Yeah.
You know what I mean by increasing function? So if n is bigger than or equal to 3, right? Yeah? What happens? What's g of 3?
G
Is
of
equal
three
to
is
negative one.
Negative 1, yeah? What's g of 4?
G of 4
Zero.
0.
So
G
plus
of 5?
G of 5 is
7.
7.
Yeah.
So the point is it keeps going up, yeah? Yeah? So that's what he proved by induction, that it was increasing. Yeah?
Oh yeah. Okay, it's just proving
Really?
a very simple concept, but with
Yeah.
induction.
Yeah, so you can maybe try it at home, but it's a very simple concept, right? This is increasing.
Oh, yeah, I get it. Because it's prime.
What prime? What's prime?
Actually, wait.
So
So,
nothing to
Oh,
do with
it's
prime.
increasing because exponentials grow faster.
Yeah, it's because
than
2 is to the n is bigger than the n squared, yeah?
well, for obviously n is greater than 2. So,
n
yeah.
greater than
Yeah,
3.
it's so much bigger that. Okay. So can you see that this?
Just sketch the graph.
Nah, that's retarded.
That's
Forget
dumb.
How's that done?
And it's also pictures, so you don't need to.
it. It's inaccurate. Just go with the solution. The solution is
Yeah, so you can prove by induction, for example, that it's increasing. Okay.
To show
Wait, how?
the graph is increasing is sufficient.
just say that Q to n is.
Well, you don't have.
increasing
Well, like
faster.
if you keep showing, like if you look at what condition for increasing is, and you keep manipulating, you end up showing some really simple inequality. Okay, and you can prove it by induction, you can prove it by however you want. Yeah.
Boom.
Okay. The point I want to make is, okay, if you didn't know, like, so basically, if it's increasing, it's also 1 to 1, right?
Strictly
Okay.
increased.
Strictly increasing, yeah. If it's strictly increasing, then it's also 1 to 1, so it can't repeat any of its values, right? Does that make sense? So
Yeah.
if this is true, right? Basically, it means 2 equals. It means f of q equals q.
Boom.
Right?
Yeah.
Okay. So the one thing you have to worry about, though, okay, this is the one mistake that they made while they're writing the solution, is it's strictly increasing for n is greater than or equal to 3, so it's injective for n equals greater than or equal to 3, right?
Yeah.
Inject me.
So if you show that q and f of q are both greater than or equal to 3, then they're the same, right? that make sense?
But what if Q is 2?
So Q is obviously greater than or equal to 3, right?
Yeah.
You know 2 goes to 2, yeah?
Yeah.
Yeah.
So
So, but we don't know that f of Q is greater than or equal to 3, right? So you have to, and then you know f of Q is greater than 3 because we know only 2 goes to 2.
2 goes to 2. You need to make
Right.
that.
Or you can say like, like the G of 2 value is different than them. Even though it's not increasing, it's still different, right? Because what happens if you put 2 in here? Actually, is it different? It's not
No,
different.
it's
It's 0.
0.
So it might be 4. That's the problem. Yeah, 2 and 4 are indistinguishable. But then 4 is not a prime, so that's okay, right?
Yeah.
So there's lots of ways to argue that. Does that make sense? But you have to be careful. So it's not enough just to say. So this argument, like if you say f of 2 equals 2, right?
Yeah.
You don't say anything about only 2 goes to 2.
Oh, okay.
Okay.
Then there's a problem.
And you just say 2 goes to 2, right?
Yeah.
And then you say it's increasing for n equals greater than 3. And then you say you're done, it's the identity, right? That's not enough. Okay? Because some of them could go to 2, right? So the 1-to-1 is only for n equal to greater than 3, yeah? So you need some extra argument to say why it's not equal to 2.
But like you can just show a few values like this, and it's like.
No, but that's not the point. You understand?
Oh, okay.
If you know to do it, it's trivial.
Oh,
Yes?
okay.
But if you
that's the
don't know
point.
to do it, it's
You
wrong.
You can lose marks for it. So like,
It's more important than losing marks. It's you're actually wrong. Okay? Does that make sense?
Yeah.
So, and of course, you should lose marks if you're wrong. Yes.
Haha.
But like,
Well, which means you just write.
yeah. I mean, obviously, it's kind of minor in the grand scheme of things because
Yeah.
the big idea is important, right?
Yeah.
But if you're consistently getting the big idea right, then this is the only gap to fill. So it's big relative to the gap now, right? Yeah. Okay. So there's two ways of doing it. You can either say only 2 goes to 2, or the only thing it could conflict with is 4, because all the others are bigger than 7, right?
There's a lot of ways to do it.
Yeah, lots of ways to do it. So it's a but
The important thing
Yeah.
is you know to come.
Yeah,
know
so
to do it.
it's almost like
I
if
know.
you said it's trivial that nothing goes to 3, yeah? Even though that's technically not that trivial, but like if you said it was trivial, that would get you the mark because at least you thought about it. You didn't leave the gap, right?
Or even if you
Yeah.
said it was trivial, you probably.
At least you know there was something, right?
Yeah.
Whereas some people might have thought it was trivial if they knew to do it, but they just never thought to do it, yeah?
Yeah, that's.
Okay, and that's what we're trying to. That's where like So obviously this is a 9 out of 10, but that 1 out of 10 is not. You don't have to lose it, so let's go for it. Yeah. All right, let's just keep it there.
You just give the answer and say the answer is f of x is equal to